Okay, let me get to the review of this month, which was primarily geometry. We covered the...
That's my cue to leave. I don't want to hear about triangles and squares.
No, these are circles, squares. We had the semicircle, we had the triangle, and the bottom line or the main message was no one has any idea what those geometries are. Why? Well, now we're going to get into the questions that people ask, and you'll see why and the kind of answers I'm going to give them.
But they're not just devil's advocate questions.
No. Even if they're devil's advocate question, they're fair game. Yeah, they're fair game. I don't have a problem with that. Yeah, if the guy wants to, take it to the limit.
Yeah, some of those questions, like, what do you need the answer for that?
Yeah. Okay. Let's go to the limit. No problem. Okay. This fellow says, what is the difference between geometry and physics? Okay, geometry has irrational foundations. Okay, why? Specifically, the point, the line, and the plane. What's a point? A location. What's a line? An itinerary. What's a plane? A hollow boundary. Okay, so are any of these geometric figures? Figures. Is this what we understand by a geometric figure? An itinerary? A location? Is that a geometric figure? And so we have a problem because they point to a geometric figure, but the description or the definition has nothing to do with what they're pointing to. That's the main point that I'm trying to get through. So that means that the foundations are irrational.
You're saying specifically a point isn't a dot, it's a location, which is a concept. You're saying a line isn't a static, continuous line.
Yeah.
It's an itinerary where you place a whole bunch of dots.
Yeah.
And a plane is a hollow boundary? What is that?
Yeah, it's just a perimeter. But what is the perimeter? It's just an itinerary going around. In the case of a circle, it's just a orbit and so on. In other words, it's a bunch of locations. Locations of what? Of a point that's going around. So what's the point? It's a location. We have a location going from location to location because there's nothing in the location.
So it's a bunch of verbs and counting with no shapes, I guess.
So that's my argument. Okay, the foundations of geometry are rotten. Why? Because they try to merge physics with mathematics, and those two cannot be merged. Mathematics is a language, physics is a science. One has nothing to do with the other, and they cannot be merged under any circumstance. Okay, so geometry is the vain attempt to merge mathematics, which is what? Quantitative descriptions, with physics, which is a qualitative explanation, or a bunch of qualitative explanations. Geometry is not a part of science because geometry doesn't explain any phenomena. Okay? Science is explaining, and geometry doesn't explain. Geometry just does a description, and what does it do? It's just an exercise in ratios and relations. You look at angles, you look at lines, how long a line is, that sort of thing. Okay, so there is no explanation coming out of geometry, except when Mr. Einstein tried to say that gravity is a geometric theory, and we'll get through that, I guess. Physics, on the other hand, is a branch of science, rational explanations of what? Of mechanisms. You have to explain something, and hopefully in physics, what we explain are mechanisms.
The other guys end up with a movie in his head, and math doesn't give you any movies.
Yeah, it's just you look at an angle, you look at you calculate, if you have a ratio between two lines or whatever, things of that nature, and all those are descriptions in the best of cases. You have no it doesn't explain anything. It doesn't explain gravity, except for Mr. Einstein. It doesn't explain light. It doesn't explain, or how light works, for example, the slit experiment, or, polarization, anything like that. It doesn't explain gravity. It doesn't explain magnetism. What are you going to explain with geometry? It's just you could say a study in calculations related to angles, to sizes of things, ratios, relations, that sort of thing. Just a description. That's all geometry is. Okay, so let's get to the specific issue. This fellow says, if I can get this thing in here, okay. In geometry, a point is a location. He's saying that, okay, and he got this out of somewhere, and I said the same thing the other day, but yeah, that's what everybody understands. It's a location that has what? Zero height, zero width, zero length, zero dimensions. So far, he described nothing. That's, I guess, the definition of nothing. Zero, nothing. That's zero everything. So concepts such as locations don't have dimensions. I mean, does intelligence have dimensions, length, width, and height? Does energy have dimensions? Does mass have dimensions? Does a field have dimensions? What dimensions? Length, width, height? What dimensions do these concepts have?
X, Y, Z was used for graphs.
And then that which has no dimensions is not a figure. So if a point does not have any, it doesn't have has zero width, zero length, zero dimensions. Well, so far you described nothing, and nothing is not a figure. So there you have the point of geometry right underneath the arrow there. That's what it looks like nothing. Okay. So yeah, you can't say that if geometry must start with a figure, you cannot say the point belongs to geometry, because the point is a location. Location cannot be described in terms of dimensions, and that which has no dimensions is nothing. So far we have nothing in front of us, okay? Which is what a black hole is, because a black hole is zero-dimensional from every point of view. Remember, Chandrasekhar proved it mathematically and got a Nobel Prize for it. So you can't go back and say, well, no, that's not what he said. Yeah, Chandrasekhar got a Nobel Prize for putting an equation saying that the star collapses to zero size. And Arthur Eddington got so upset, who was his boss, right? Who was his guru, objected to that, didn't allow him to print that stuff. He published it somewhere, and both Einstein and Eddington criticized that. And they said, no, a star cannot collapse to zero size. These are their own words. Okay, so yeah, don't tell me that a black hole is zero size. It is not zero size. It is. Okay, it collapsed. There's nothing stopping it from continuing to zero size, because all they're going to talk about is mass, not about the structure. So if it collapses to a point, all you have is a location.
Well,
The center,
geometry.
Yeah, but that's part of geometry. In other words, they're saying that because geometry enters the picture, especially in string theory, where you have this collapse of a star, it collapses to a point. Point geometry, right? Geometry. What's the point? Location. All we have is a location full of mass, a concept full of another concept. So yeah, that's how this stuff seeps into the language from geometry. Okay. Okay, here's the line. Okay, a big important line, very important in so-called geometry. What was a line? An itinerary. Okay, a line is defined as what? A line of points. What was a point? Location.
Wait, a line is defined as a line?
Well, line of points. He means like a bunch of points. That's what he wants to say. Like a sequence of points. That's what he meant by line of point. But yeah, what he's saying is it's a bunch of locations, because we just settled that a point is a location. So we have a series of locations. What is that? That's an itinerary. That's not a line. Okay, but they put a line, a geometric line, usually a continuous line, to represent that when there is no such thing as a line made of a single piece, a continuous line.
They use a lot of representing. I think they represent a lot, which is code for cheating.
And that's the word they use. They say, no, that's a representation of a line. That's a representation of a point. What do you mean a representation? Either it is or it ain't.
Yeah, why bother with representations?
Yeah. And then he says that extends infinitely. Oh man, extends and infinitely. We have two problems there, okay? In two directions. It has one dimension, length. Now, there's no geometry that has one dimension, okay? So if a line is a bunch of locations, points, right? Then the line doesn't extend, okay? Only objects may be said to extend, okay? You're talking about something else, not extension. Extension is when you extend your bubble gum. That's extending, okay? But here we're talking about something else. A series of locations is not a geometric figure. Okay, and that's what a line is, according to that definition there, which is what people have out there officially. Series of locations known as an itinerary. An itinerary does not have dimensions, length, width, or height. Dimensions are the sole province of objects and figures. Only objects and figures or things can have dimensions. You cannot say a concept like intelligence or information has dimensions. It's irrational. Infinity, or infinite, is an adjective. In physics, it is irrational to use it as an adverb. See, you can't say it's infinitely, like you said there. No, what he meant is something else. A series of points go on forever, incessantly. You have to use an adverb. You can't use an adjective that you force.
What's the difference between infinite and incessant?
Well, the infinite is referring to an object. You can say, assuming, right, that an object is infinite, which is a contradiction, because all objects are finite. But you can apply it to the word object because it's an adjective. You can say this object is infinite, meaning that it extends forever.
It's devoid of verb.
Yeah, in other words, it occupies the whole universe and beyond. It's like this object is infinite. You can use it in that sense, and that would be irrational because all objects are finite. But you cannot say I run infinitely. You can say I run eternally. You can say I run incessantly. You can use adverbs for that. You can't use an adjective and turn it into an adverb in these contexts. That's what he meant by extends infinitely. So, the language is important here.
Well, extend is a verb, so I guess if you took it literally, it would be like the bubble gum stretching forever.
Yeah, but even in that case, it doesn't...
It would be incessantly.
Yeah, it extends incessantly. You can't say infinitely, okay?
Is infinitely even a word?
Yeah, it is a word because it's used by mathematicians who talk about the number line, like saying, for example, the real numbers, they extend forever. You can continue counting until you die and beyond, okay, even when you go to heaven. Okay, here's a line, and what is it? A bunch of locations. So what we have is a turtle at different locations. That's all we have for a line. That's the definition of line we have today, just locations. So what they've done is they turned that into a solid stick, okay, which is not true. It should not be like that.
You mean a series of locations that something goes through, I guess you could say.
Yeah, in other words, the line of geometry is just a bunch of locations. And all you're saying is that we have a turtle there and it's got different locations. And that turtle, if you were to put it in each frame of the Universal movie, that turtle would occupy one frame for every split second. Yeah, for every location it's got.
Between each split second,
there's another location. So all you have is more frames. And every frame...
Why make it so complicated? What fringe examples do they need to go to such lengths for?
Because they wanted to incorporate physics with math. In other words, that's what geometry is, an attempt to merge the physical part, which is what you can see, the figure, with what they're going to do, which is, we want to look at ratios and relations. Mm-hmm. And so they said, well, this has to do with math because we're going to be doing angles and calculating sines and cosines. And this has to do with physics, which is the object itself. Mm-hmm. And today, that's why we don't have any objects in so-called physics, in other words, mathematical physics. They
extracted all the ratios and then they just left the objects.
Yeah, and they don't pay attention to the objects because a mathematician doesn't deal with objects. And that's how we ended up with this, which is the circle. Let me put it over here, cover your face. Okay, why? Because what are you staring at? Well, you're staring at an orbit. And what's orbiting? A location.
What?
Location. A location
is orbiting?
Yeah, the location is orbiting. Location is at different locations. Because the dot is not there. The dot is there to represent the location. What is a location? It's just the location occupied by a location because there's nothing in that location. Okay.
I'll take a shot every time someone hears location.
Yeah, and so here you have the square. Okay, that's what a square looks like. It's an itinerary.
We're just talking about a location following location.
Yeah, that's what it is. That's all it is. And here we have the triangle. We cover that. Okay, there's the triangle. Okay, so all we have is a bunch of locations. That's known as geometry. Those are figures that you stared at. That's what they're saying. So we have a rotten foundation for geometry. And you're saying, well, who cares? Because what we're interested is in the ratios, in the relations, all that stuff. Yeah, but see, we have a problem because then they extrapolate that to physics, and they start telling you that gravity is a geometric phenomenon. That's where the problem is. That's where the danger is. Okay, because they say, oh, it's geometry. Where do they get? What is a string? And they say, well, it's a line. See, it's not a string. It's a line. Okay, let's get this straight. They use the word string. You say, okay, I know what a string is.
String theory?
String theory. Here you have, that's a string, right? We all understand what a string is, okay? You see it there? And they say it's a string. And we say, okay, I understand what a string is. In fact, a lot of people think that these people are talking about strings. They're not talking about strings. They're talking about line because they're doing all this mathematically. You're not supposed to, the string is there to represent what the line.
That word again, represent.
Yeah, it's to represent the line. What is the string? It's a bunch of locations. It's an itinerary. And what they're doing is they're vibrating the itineraries, and that's the particle. The particle is a vibration of an itinerary. And until you understand it, you don't understand string theory. String theory has nothing to do with objects, with strings. String theory is a geometric theory. Okay? So geometric theory that tries to explain gravity, that's trying to unify general relativity with quantum mechanics. What is quantum mechanics? They use the dot. What is the dot? It's a location. The dot is the representation of a location. They call it a particle, but you're talking about what? An equation. And they're trying to unify that. They're trying to quantize space-time, meaning they're going to take space-time, they're going to chop it up into little dots, quantum dots. And with that, they're going to try to explain how a black hole works. Because what they're interested in, that's where they think they can merge the two. The black hole has the singularity that they get from quantum mechanics, and it has the space-time curvature that they get from space-time, from general relativity. And so they're trying to play around with that mathematically, and they say, well, okay, we came up with strings. What do you mean by strings? What's an itinerary? It's an itinerary. What do you mean an itinerary? It's full of locations. And what they're going to look at is these relations between the itineraries and what happens inside a black hole. That's what they're doing, because they think that's where the what is it, the golden, no, what was it, I can't, there's a term for the golden, not the golden fleece. I'm thinking it's their goal. Their goal is, to merge these things, and to merge quantum mechanics with general relativity. And the way they do it, through geometry, because they say geometry works, gravity works in space-time, works in general relativity. And here we have the point, which becomes a line. That's geometry too. Hey, all we got to do is put them together. Okay, that's the issue. That's where the danger is with geometry. They're introducing it into their physical interpretations and misleading you again, because they're not talking about objects at all. There are no objects in mathematical physics, not one. All the objects of mathematical physics are what? Particles, which are equations; black holes, which are singularities, mathematical singularities; space-time, which is what? What is time? Is that a physical object? No, that's a number. And so on and so forth. It's all equations. It's all mathematical what they call objects. No, it's not a mathematical object because object is something else. But they turned it into a mathematical object so that they could give you a physical interpretation. And what do they use? They use words such as, well, that's a field, and that's energy, and that's mass. And you think they're talking about objects. No, they're talking about mathematical concepts, quantities, which is what they can put in their equations.
Was Holy Grail the word?
That was the word, the Holy Grail. Yeah, that's the Holy Grail of string theory, to try to merge, quantum with general relativity. Okay, here we have another question. And it says, the word science does not mean and will never mean rational explanation. Science, the episteme or epistemological, I guess, is knowledge. The so-called man of science is simply the man who knows.
Where did this come from?
Yeah, this is a fellow who put this comment there. And the answer is no. Okay, first of all, the word knowledge has never been defined. To this day, we don't have a definition for the word knowledge. So you can't use an undefined word to define science. Even though the word science comes from scire, which is the Latin for knowledge, that's when the Greeks and the Romans screwed up, because science has nothing at all to do with knowledge. And that's why we have to define these terms to find out what they meant and what it means today. Today, we don't have a definition for the word knowledge. Everyone uses Plato's justified true belief. That's the definition of the word knowledge today. And knowledge is equal to belief, essentially. Knowledge, when you know, means that you have a belief. Because the other guy on the other side of the planet, his knowledge is a little different. His belief is a little different. So when you say that you know for a fact, that's your religion.
We had a really long talk with some friends, and my brother kind of had a really good example talking about flat Earth theory. How back in the day, in medieval times, they thought the world was flat and the Earth was the center of the universe. He said back then they knew the world was flat, and now we know it's not. So what does no mean?
A lot of people know that God exists. You can't even talk about it.
That was trickier, but I'm just saying the flat Earth one is a good example because that one is basically by a democracy. How many people raise their hand up for this belief? That's the no.
Yeah, and you can do that today. You have the flat earthers today, and they don't believe the earth is round. And you say, hey, I know the earth is spherical. I know the earth is round. And they'll say that I know differently. So who knows?
Yeah, but when we kept saying, what's wrong with using the word belief? And they're like, but that just sounds so wishy-washy.
So
they didn't like that word. That's not a good word for like science and technology.
This is the danger.
I believe if you walk up as the architect of a building and say, I believe this won't fall, that's less ensuring. I know. I believe it. What do you mean you believe? You better know, motherfucker.
What do you mean you believe?
Yeah, it's like a different weight to it, knowing.
Yeah. And so here, let's complete that. Here we have it. Okay. So we have to define these terms. Knowledge. What is knowledge? This is according to my definition. Okay. Knowledge, predicting the result of an experiment without error. Okay. That's what knowledge means. That's always meant.
But that's in retrospect.
Yeah. What we're saying here is that if you want to show your knowledge to someone, how do you show it? How do you show to the professors at the university that you know? Are you just going to say, well, I know that Napoleon went to Waterloo? Well, how do you know? I mean, did you just read a book and memorize? Were you there? How do you know that Napoleon went to Waterloo? So you cannot talk about knowledge in past tense, in consummated events. You can talk about explanations, you can talk about descriptions, you cannot talk about knowing that Jesus Christ was hanged, that Caesar went to England. You cannot talk about knowledge in that sense.
You mean you're repurposing the word so that you can only use it for something you can predict?
Yeah, and the only purpose of the word knowledge, and the only way you can use it consistently, is saying, look, I can predict what's going to happen. For example, if I let go of a pen. I let go of the pen, it falls to the floor. I know it will fall to the floor. And by that you mean that you can predict exactly that. Every time you let go of the pen, it falls to the floor. It turns out that you're even wrong there, because you say, okay, I'll bet you $1 million this is going to fall to the floor. And it turns out a comet hits the earth and neither one of you collects your bet. Because the pen never made it to the floor, the comet destroyed. You didn't know the comet was going to hit the earth, for example. So you cannot
believe. You didn't believe the comet.
You believe that or it turns out that you have a horse, right? And it turns out that you say, I know that horse is going to win the race. And that's because you maybe bribed all the other jockeys, or you put some device that hurts the other horses or whatever. And you say, okay, I'll bet you $1 million your horse doesn't win. Your horse number 5 won't win. And the guy says, okay, I'll bet you. And the horse is about to reach the finish line. I pull out my gun and shoot it. It never makes the finish line. And the others just walk right through. Even the turtles pass them. So you didn't know that the horse was going to win.
So the way you use the word no, you can't. It would be incorrect in the sentence. I know the pen is red.
Right.
Because you can't predict the redness of the pen.
Well,
so it would be a misuse of the word.
Again, in that, right, it's a misuse of the word because that's a description. We're talking about predicting something that's going to happen in the future. Okay, so that's what I'm saying knowledge means. And that word there has nothing to do with science at all. Science deals exclusively with the past, with consummated events. There's the definition, deals with theories, explanations, the causes underlying a mechanism, physics, or reasons that led to an event, philosophy, or the prosecutor's version of how or why an event happened. Happened, past tense, ed, okay? Description, what we don't do in science, is a listing of properties or behaviors of an object.
Well, you do that too.
Yeah, but but that's not the core of science, and people mistake the core of science, and they say, well, we have to describe it. And I'll get to that in a minute here. In fact, so I'm getting ahead of myself here. Let me get that out. Okay, let's get to the next issue here. One person talks about wrong and right. What's wrong? What's right?
Yeah, it doesn't have to do with facts.
Well, we'll get to that.
One of the comments talking about the difference between the Earth being flat being a belief or a fact.
Yeah, okay, we'll get to that. Okay, it said that whoever, this is the comment the person made, said that whoever has a degree in science wrongly defined is a scientist, or whoever is employed in a scientific laboratory wrongly defined is a scientist, or who simply deals with scientific topics wrongly defined is a scientist. All wrong. Okay, first thing, wrong is an opinion. Right, wrong, that's your opinion. Okay, so whenever you use the words right, wrong, correct, incorrect, true, false, all those are opinions. That doesn't enter science. That's totally religion. Opinion, belief, religion. And then the second part of that is that this argument merely corroborates that the word science has never been defined rationally. Because if those are the definitions people have out there, then we don't have a definition for science, if that's what people think that a scientist is. Okay, so let's get on to another common question here. Give me a second. Pull it from the bottom here. Fella says, tries to define, says, science is well defined. Yeah? No kidding. And all the dictionaries in the world say more or less the same thing. Okay. Change the meaning of a word that humans have been using for a few millennia. It is impossible. You have to use or invent something else.
That's kind of what I keep saying too.
And I'm saying no. We have to fix what is broken. Science is defined irrationally. We don't have a rational definition of the word science, and we have no scientists on planet Earth because they're all following this religion which people call science. Oh, I thought for a moment it was cut off. Democracy voting, you know what this guy's referring to, has nothing to do with science. They're not scientific criteria. You can't say, well, we're going to vote.
We're going to vote on what the facts are?
Yeah, no, on what the word science means. We don't vote in science. In science, you have to fight for your definition. You have to get into the ring with your sword, your shield, right?
What does that mean exactly?
Well, you have to fight. You have to defend your definition. And if someone shows in a rational way, in a logical way that your definition has a contradiction, I'm sorry, you can say, well, I still believe in it. Yeah, you can believe in it, but you're not in science. Now you're in religion.
Because there's a contradiction in what you're saying.
Right, the guy shows you that you have a patent, the obvious definition, contradiction in your definition. And then, again, you can't use tradition and authority, which is what this guy is saying. He says, you're trying to change the meaning of the word that humans have been using for
centuries. This is how we've always used it.
Yeah, that's not an excuse. That's not an argument.
Well, because we're not talking about the word exactly. We're more talking about the notion.
Right. What do we mean by science?
What is the idea that we're trying to box into a word?
Exactly.
So we don't really care about the word.
Right.
It's more just what's the notion that we're trying to get.
And what I'm saying, if it's broken, you got to fix it. Sorry.
So we never had a good criteria for this notion.
Right.
This is what you're saying.
And so we need to define what science is. And that's why you have to look at what the science tried to achieve. And I'm saying everybody that deals with science wants an explanation. We want to know how gravity works. We want to know how light does its magic. All these experiments that people have seen out there, observations, whatever. They say, well, tell me how Mother Nature's doing that trick, that magical trick, right?
That's why the mathematical physicists also always go into how things work.
Yeah.
At the end of the dissertation, at some point they say, and that's how a magnet works.
Yeah, but then when you tell them, hey, but the explanation you gave me is irrational, they say, well, that's philosophy anyways. Or you're not supposed to take it literally. They give the answers
the representation again. Oh, there we go again.
That's why we need to define the word science once and for all. And today, science is really religion. That's why we need to define the word science. People have this mistaken idea that science is about convincing people, persuading people, that's what science is about, saying, we proved it.
Yeah, enough people believe it.
Right, and raise their hands and vote.
That's one that's thrown in my face a lot. Whenever I bring it up with my friends, it's like,
is that what so many black eyes?
So many people believe this, you're gonna think it's wrong. It's one of those things like you're crazy, one of those things. I don't bring it up a lot, but when it comes up, it's like, That's not really a good argument.
It's a delicate point, right?
Yeah, it's like it's not really an argument. A million people believe this. Does that make it true? You know?
Yeah.
I mean, I guess the flat earthers also have that problem.
Yeah, again, it's like religion. You know, you have all these different religions. This guy believes in Mohammed, the other guy in Gautama, and so on. You know, and what are you going to say? Oh, I've got the truth. You got the lie. I'm sorry.
Well, yeah, but again, it comes up to a lot of points like cigarettes. For the longest time, people thought that cigarettes were healthy, but then the belief changed. Like, okay, we're starting to kind of see more facts.
The tar.
Yeah, once you start coughing your lungs out, you're like, maybe it's not that healthy, buddy.
Okay, Thal brings in the issue of observation. Okay, another issue that's very touchy in the word science. At first, it seems rational that facts and observation have no place in science at all, and that science is only rational explanations. But without observation, what is there to explain? Oh, very important question, because this word observation is a killer. People think that observation has something to do with science. So I'm going to give you 3 arguments. I have more arguments. I'm just going to give you 3 arguments of why the word observation should be eliminated from the lexicon of science completely. We don't need the word observation at all. Here's the first one. Okay, here's the first argument.
I don't know how you define it, though.
Well, I'm getting to part of that. Okay, here's the definition of what observation means. So this is argument number 1. This is the wrong context for observation. In the religion of mathematical physics, so-called science, the word observation is a synonym of proof. It's a weapon that is used against you. Observation means, I have proven my theory and you have no say in the matter. You have to believe it because we proved it through an experiment, and here's the equation to verify our observation. The theory is now a fact. Deal with it. That's what observation means. Okay? So whenever you hear observation, they're trying to shove a fact down your throat. That's a theory down your throat turned into fact. That's what it is. Okay? You have the theory of evolution. Is that a fact? Well, you'll have a lot of these people say, well, it's a fact. No, it's not a fact. It's a theory. And they say, well, theory is like a belief. And so they don't like the word theory. They say, no, it's been proven.
But what is a
fact? What do you mean proven? Proven, you mean it turned into a fact?
What is a
fact? For whom? For you. Well, a fact means that it's a done deal. Like you can't contest it. You can't challenge it anymore because it's a fact. We've proven it. It's proof now. It's fact. It's a done deal. And it's like you can't challenge it because, evolution is a fact. No. Evolution is a theory. There's another theory that says God made Adam and Eve, right, with a magic wand, and he put them on earth. A lot of people believe in that theory. And this guy says, well, I don't like that theory. Yeah, well, yeah, but that's a fact for this guy, and this is a fact for you.
Maybe the word fact needs better definition.
No, we need to get rid of the word fact, proof, observation, because observation means fact, proof, means your theory turned into a done deal. That's what it means.
Well, usually when someone says fact, what I understand under the notion fact is what Mother Nature knows, essentially what God knows to be true, whatever that means. It's what none of us could really know for 100%.
She knows for a fact.
Yeah.
What happened. It's in her file cabinet.
But it's kind of like in like problem-solving math books where they have the answer on the back. God has that answer, but we never get that answer.
Right,
you can
only believe.
Yeah, you can only get close.
you can throw ideas out there and say, well, I think it's this. The other guy said, I think it's that. And that's fine. But to say, no, mine is a truth. Yours is not a truth. Mine is a fact. I turned my theory into a fact. Well, this guy has a different fact.
It's just too wishy-washy. It's all about beliefs.
You can't talk about knowledge. You can't talk about proof. You can't talk about fact in science. That all belongs to religion. Yeah. Why do we do experiments? To get evidence. Why do we present evidence? To persuade the jury. Religion.
Or ourselves even.
Yeah, or ourselves. Yeah, right. But I mean, what's the purpose of evidence? To persuade. That's what we use evidence for. That's why experiments and evidence have nothing to do with science. We don't do experiments in science. I know people say, what are you saying, Bill? How can you say that? Yeah, we don't do experiments. We explain them.
Well, because you
have to explain.
Because you could do logic with assumptions. You don't really need...
Yeah, I'm getting to that in a second, but let me give you an experiment. Here's an experiment, okay? There's an experiment. I can do it repeatable to make it very scientific. Here it goes again, okay? Okay, so what did I learn? That the pencil falls to the floor? Do I know why? Can I explain the cause that brought the pencil to the floor? Do I have particles pushing on it? Do we have strings pulling on it? By doing an experiment, I have not done science yet.
You didn't see the angel; it was grabbing it.
Yeah, I can say that too, and I can say that. I can say it was angels, and the guy says, "No, we've proven it was particles."
But none of these theories are a fact.
Yeah,
one of them is actually
mine is the one that's a fact.
That's not true. One of those theories is the fact, but we'll never know which one is the fact.
Mine is the one that's a fact always. For me. Yeah. No, you can't use knowledge, fact, or proof. Not in science.
I like fact because fact is like, again, the answer
That Mother Nature.
Yeah, the Mother Nature knows.
God knows.
We'll never know which one the fact is. We can just like
Mother
I think this
Nature,
is the one
God, the devil, all those people know, but we don't.
A lot of people know.
But they're up there. Yeah, we'll never see them. Maybe when you get to the pearly gates. Okay, here's argument number 2.
Are those going to be your first words in the pearly gates? Was I right?
See, I knew it was a fact. Okay, here's
Now send me down. I can prove it to everyone else.
Okay, here's argument number 2. Stephen Hawking was a guru in black holes. Stephen Hawking never observed a black hole in his life. No one has to this day. Stephen Hawking what? Inferred that there was an unimaginable zero-D object that mediated unexplained cosmic phenomena. Stephen Hawking simulated stars twirling around and losing gas from the skins to this zero-D entity. Okay? Therefore, again, the word observe is used as a synonym of proof and fact. You cannot challenge the black hole hypothesis anymore today.
Someone already saw it, so it has to be real.
Yeah, you have to remember that the black hole has always been inferred indirectly, and they'll tell you that. They have no problem telling you that. They'll, all these people like Genzel. The other day, he won a Nobel Prize. Well, one of those. The other one was what was his name? Roger Penrose. They won the Nobel Prize for what? For inferring indirectly. That's what their papers say. That they inferred indirectly that there is some massive object that we can't see, that we can't touch, that is zero-dimensional, that has all this mass, that's moving stars around.
But by definition, you can't see a black hole. So you have to infer it.
Even that's wrong, because then you have Stephen Hawking says that you have this light coming out of there, that black holes, suck. When it pulls a photon, the photon breaks into 2 virtual particles. One is the positron, the other one the electron. One is sucked in, the other one flies out. I don't know why it flies out, because all the gravity should be pulling it in.
Now it's massless.
But yeah,
that's but a good example is air, where no matter what tools you use to see air, you can never see it. You can only just see its effects.
Yeah.
It's always inferred.
Yeah. It's a theory that says there are atoms here, and I'm breathing atoms, that there are these particles that are flying around, and it's a theory. And the guy might say, well, it's a fact. No, it's not a fact. It's a fact to you because, a proof that can't be challenged, and you say it's a fact. No, you can't say it's a fact. You're putting a theory saying, look, let's assume there are particles called oxygen or whatever, nitrogen, and they form this gas that we can't see, and I'm breathing it. And I pass my hand, I can touch it, I can breathe it, but I can't see it. And so that's your explanation. That's yeah, but it's an explanation. It's nothing but an explanation. As soon as you say it's a fact, well, it's a fact to you. Because the other guy says, no, these are spirits that we're breathing. And what are you going to say? No? And the other guy's going to say, no, it's energy, or who knows what. I mean, he can come up with anything. And that's what he believes. For him, it's not a fact that there are particles here. They say, well, that's an assumption. And he's right. It's just an assumption, and you're using that assumption to explain why you can breathe.
People don't like that. People don't like that wishy-washy beliefness to it.
Yeah, it destroys their argument.
But it doesn't sound right to say, I believe there's particles going in my nose. It's like, you feel it, you're like, what do you mean belief? I can feel it.
But the other guy says, no, it's spirits that's going into your nose. What are you going to say?
That guy's a dumbass.
Obviously, for him, it's a fact.
He's dumb.
I'm sure I go to the jungles, maybe some long-lost tribe out there that's still in the Stone Age, and you'll say, what is that stuff you breathe? The guy say, oh, that's the spirit of my grandfather. What are you going to say to the guy? You're going to say, no, look, there are these particles we call atoms. What are you going to explain to the guy? The guy believes in something else. For him, it's not a fact. And that's all there is. All you can do is have an explanation, a rational explanation, and some people subscribe to it, and some people don't, have some other explanations.
I really think people just don't like the word belief.
Yeah, because it means that, you just have a belief.
Yeah, it's not. You just pulled it out of your ass. That's what it sounds like.
No, in fact, they have that. In the case of, evolution, the religious folk come in and they say, well, but it's just a theory. And that just upsets, drives them up the walls. What do you mean just a theory? It's a fact. Evolution is a fact. It's just a theory. It's just a belief.
Yeah, but what's wrong with that?
Because theory does not mean belief. Theory means explanation.
Yeah, that's different. But
once you define theory as an objective explanation, then you have no problem. But as soon as you put in there and say, it's a fact, I turn my theory into a fact, then you run into trouble.
But again, I just don't understand the what do you call it, reservation of using the word belief. Because it's not enough.
It means it's just your philosophy.
Yeah, it's not enough. It's not enough to say, I believe I'm alive. What's wrong with that? Why do you have to... I don't know. It's not enough.
Okay, and here's the last one. Last argument for that. Okay, if I can get this down here. Okay, and this is the mafia principle of science. Observation equals testimony equals witness. You can't introduce witnesses in science. What you do is you follow Al Capone there, and he said has the mafia principle. Kill the observer. Kill the witness. No witness should reach the stand.
You're saying logic can be done without observations, we do it all with assumptions. So observers just muddy the water. Is that the issue?
Well, let's put it this way. We have a blind man. Okay? Now, he has trouble using his eyes. What are we going to talk about with him about the moon? On the other hand, you tell the blind man, you say, okay, look, there is this moon that's going around the earth. Okay? And I don't know why. And maybe he can explain to you why that moon goes around the earth. He never saw it. He just reasoned in his dark world. He never saw the moon. And you just explain to him the observation, what you saw. He hasn't seen it. Like Stephen Hawking never saw a black hole. But he can reason it for you. He can theorize it for you and give you an objective explanation. So that's where science stops.
So you're saying in this case, he's taking your observations as assumptions. So, like, okay, let's assume there's a big thing up in the sky. Let's assume we're a big rock.
Yeah.
What could be the explanation? Taking these assumptions, what could be the explanation for this phenomenon of one ball going around the other?
And that's the issue.
And he's felt strings before, so you'd be like, okay, it might be this, for example.
And we don't deal with observations. We deal with assumptions. The word is assumptions in science. In science, we have no observations. We kill the witness. We burn his eyes. We don't want to observe anything. Okay, observe means you're going to introduce testimony, witnesses. You're going to introduce what you saw. And imagine these people say, well, we saw. They don't use the word saw. They use the word observed, which is very tricky because they say, we observed a photon zipping by. And you say, well, what do you mean you observed a photon? Why do they use the word observe? Because it gives you that hint that, hey, we did see it with our eyes. That's what a lot of people out there, especially common folk, that's what they understand. They say, oh, they observed the photon going by. I thought it was an assumption. No, these people are making an assumption that there is such a thing as a particle called a photon, which is not a particle, by the way. But they use the word observe, and people say, well, the scientists observed it in the lab. Well, who am I to question that? That's how they use it as proof. They use eyewitnesses. I'm giving you my testimony. You're going to doubt my testimony? I'm a scientist? That's what they're saying. That's why the word observe should be eliminated from science. We don't use the word observe. We use assumptions, and we do not need to observe anything to make a theory, to explain something objectively. That's all that science is in the end. Okay, another fellow puts something along these lines. Lots of questions along this line. Scientists and science, says, putting yourself in the shoes of a scientist, living at just the dawn of powerful microscopes, what would you say about looking into a glass and seeing these animals? Kind of like what Robert Hooke did with micrographia. He just looked at stuff through the microscope and found a lot of stuff. He even looked at tobacco plants and so on. Well, this is the answer I give you. I would say that you should not call him a scientist. It's premature. He will be a scientist when he can explain the mechanism underlying what he observed. Why did you call him a scientist? So far, all he did was just is just a lab boy. He's just a gopher doing data collection for his master. So far, all he did was gawk. He saw something. Is that science just because he observed something? You know, observation is not science. Science is explain something. Explain what happened. Explain a mechanism objectively so that I can understand it. Not so that I believe it, so that I understand it. And people have problems with that because they want to introduce their religion.
It sounds so simple the way you put it, but it goes off the rails when...
Well, because people are not used to explaining objectively. People simply want to tell their religion. They want to say, well, this is what I believe. I believe it because all the scientists believe in it, and they proved it in the lab. That's essentially the argument of everybody out there. And that's not science. That's known as religion. In science, we say, look, let us assume there's this, and this is my theory. This is my objective explanation for how this took place. For example, magnetism. For example, gravity, light, electricity, the workings of the atom. So you're trying to explain something objectively, not so the person believes, so that the person understands the mechanism. Then he can reach his own conclusion in his own dark basement. You don't have to influence him. He'll reach his own conclusion on his own, based on his upbringing and education. Okay, and so here's another. Stars on the galactic rim travel as fast or faster than those in the center. So far, that's what a description. So far, you haven't explained absolutely anything. Or you're saying, I saw something. Here? Well, again, the context here is this science? Is this observation? Is observation science? The guy that says, I observed.
He just stated an observation.
Yeah, he says, this is what we saw. Yeah, should we put a period there and say, okay, we did science. Let's all go home. Let's get our Nobels. No, so far all you have is a description.
There's no question. There's no explanation.
Right. So this is just a description.
If someone asks why do the stars on the outside travel faster than the center,
then it's
a scientific question, and the answer to that would be also science.
Yeah, because you would have to explain objectively how that magic trick is done.
Well, I guess that's implied that this is a phenomenon to be explained.
Yeah, but see, they stop there and they say, oh, I did science because I found out that the stars, on the rim go as fast or faster. And then does this description qualify as science? Just there where we stopped. It doesn't. That's not science, what we have so far. It's like saying, oh, I saw the chair fall down. Well, is that science? Maybe the explanation is why or what caused the chair to fall down. That would be a more interesting question. What have you explained? What have you learned? Should we give you a Nobel Prize for your observation? Because that's what they do today. They give Nobels to mathematicians for what? For discovering phenomena and describing them with equations. That's what they think is science. And so this is where they give all these prizes because they say, oh, that's science. No, that's not science. It's describing something, saying, oh, I found this specific behavior in nature. Okay, you found it, and
scientific question, I guess. It raises a question.
Unless you explain something with it, you just like you say, I'm the first one in the first person in the world to see a rhinoceros. Should I give you a Nobel for that because you're the first one who saw a rhinoceros? Say, oh, I found this animal. It's so weird. It's got this horn. And is that science? Just saying, I found a rhinoceros. I discovered it. I'm the first one. Give me a Nobel. Is that science? No, science is explaining something, finding something, tripping, and falling and saying, oh, I tripped and fell. I observed. That's not science. And that's what all these people do. They describe, they discover some phenomenon, they explain it supposedly with particles, which is not an explanation, partly because particles are not particles. And then they say, here's the description, a mathematical description, here's the equation. They say, okay, give him a Nobel. That's what science is today. And all he did was persuade his peers who think exactly like him to begin with. Okay, this fellow is also in observation. He says, see doesn't mean just with your eyes. We have all kinds of machines that see what we can't with our limited vision. Okay, so here's my answer. Can these machines see the invisible, intangible mediators of light, gravity, and magnetism? There you have them on the bottom. Okay, you have an atom, you have light, which is known as an electromagnetic wave, you have a magnetic field there. Can these machines see these invisible, intangible things? If these are things, is a field a thing? Can you see a field? Can a machine see a field? Or can it just
see the effects?
See the effects, like iron filings. Okay, and so if so, what have the machines draw? Have the machines draw these invisible, intangible mediators for us? I want the machine, not that you program it, but for the machine to do it all by itself, to see if it can infer or whatever. If it saw, it doesn't have to infer. It says, this is what I saw. Okay?
You just see
can a machine do that?
You just see the picture of light.
Well, a lot of these machines, like, you take like a photo multiplier, and I use these machines when I worked as an engineer at AMD. And what they do is they're already programmed, their algorithm inside it is already designed to detect any blip, any frequency, anything as a particle. So it just counts particles, and you're saying, well, obviously, it's counting particles, right? No, it's counting something that it doesn't understand. It just treats it as a particle because that's what's been programmed into the machine. And so they say, okay, now you have a higher intensity. That means you have more particles. Well, is that what really happened? Or is that what you programmed into the machine? I mean, it's garbage in, garbage out. Whatever you put in, that's what you're going to get out. But that's been programmed into the photomultiplier. Okay, and you have a lot of stuff like that out there. You have an ellipsometer, and it tells you the thickness of a layer, say, of oxide or whatever, a layer of film. And it's already programmed to go in there and convert light through this table known as a refractive index. And it just says, well, light went slower over here. Did it go slower? Or is that just an algorithm that you programmed into the ellipsometer so that, when it gets little c, 300,000 kilometers per second, which should be wrong anyways because that's only in outer space, not here where you have air, and air travels slower. And that goes through this film of glass, for example, right? And that says, well, it's 1.45 times the speed of light. Oh, what do you mean? The speed of light divided by 1.45, 1.5, whatever. So it's so they're saying, no, the speed of light here is 200,000 or less than 300,000 kilometers per second. Well, is that simply because we programmed into the ellipsometer, or is that what light really does? Does it slow down? And then if it slows down, why does it speed up later on again? Okay, so
we don't care about that part.
Yeah, you put energy into it and start speeding up after it leaves the glass. Yeah. So again, these are all ad hoc type of things that we program into the machines. Okay, a couple more issues here, also related to science and some geometry and so on. Okay, and here it says, in magnetic levitation of your body, you would feel it as weightlessness. And he says touch. Weightlessness, if anything, is the opposite of touch. It means you're not touching anything. What touched you? What came in physical contact with you? Please draw it. I want to know what touched you, if you're saying that weightlessness is touch. Just draw whatever touched you.
What does he
and
mean?
then
What does he mean? Weightlessness is touch.
Well, he's saying that if you're floating out there like an astronaut in outer space, he says that's touch.
What do you mean that's touch? What's touch?
Yeah, that's what I mean. I'm saying it's the opposite of touch. I would say weightlessness, if anything, is the opposite of touch. But if you think something touched the astronaut, please draw it. I want to know what thing touched the astronaut out there. That's what you got to explain, okay, or justify before we can believe your theory here. We can see the shape of magnetism with demonstrations such as you showed using iron filings. Okay, this is what I showed the other day. Let me get it up here. Give me a second here. Okay, and here you can see what's happening. Okay,
that's the one I showed you.
Yeah. And here you see a magnet, and they make all the iron filings bounce on some kind of trampoline of some kind, and you can see there the shapes that are happening. Okay, that are being created by this invisible thing we call a magnetic field. But as you can see, the iron filings are picked up one at a time closer to the magnet. Okay, you can see one at a time, they're going in there. Something is moving in that region we call a magnetic field. You have to identify what is pulling on a single iron filing. What is pulling on one iron filing? That's what you got to identify.
Ah, you're saying pulling.
Yeah, I'm saying
Might
pulling.
be pushing.
Okay, you can do pulling. I don't care if you do push. Please draw what's pulling or pushing on each, not on the whole thing. I want one iron filing. I want you to show me what physical object is coming in contact with one iron filing.
What if it's invisible?
Well, yeah, it is invisible and tangible, but this fellow says that this shows what see, here's his comment. He says, we can see the shape of magnetism with demonstrations such as this. No, don't tell me about the shape of magnetism. Tell me what pulls or pushes on one iron filing. That's the answer that we need, okay?
He can't show you because it's invisible, I guess is what he's saying.
But I mean, he's got to show me what came in contact. What does he propose? What does he propose?
But it's an invisible thing.
Well, I don't care. It's a thing. Draw it. Make it visible.
So you can't. Oh, make it visible.
Yeah, make it visible for my eyes. I want to see what came in contact. Or are you going to do it with spirits? Are you going to say there's a spirit that's pushing or pulling on one iron filing?
Well, I guess the point is it's invisible, so you can't draw it. It's like drawing air.
No, you can draw air because you make an assumption. You say this is what I propose air is. Now you draw it and you say this is what I think.
If it had color, this is what it would look like.
You're right. If it had visibility, this is what it would look like. That's what we need for you to do with whatever's pulling on one iron filing. Don't talk about a field. Don't talk to me about what pulls on the shape of the magnetic field. Tell me what's pulling on the shape of the thing that's pulling on one iron or pushing on one iron filing. That's the issue. That's what you got to draw. And again, what we saw is iron filings moving. We did not see the thing that moved each iron filing towards the magnet and formed patterns with many iron filings. Please draw the shape of the object that came in contact with one iron filing and moved it. Okay, remember that's what good old James Maxwell came up with, and so did, for that matter, Michael Faraday, who played around with magnets and electricity. These fellows reached the same conclusion. That was in the 19th century. Unfortunately, people forgot. But James Maxwell said it very clearly. There is matter in motion. That's what a field is. Matter in motion.
You can see it in that
something is moving in there.
Something's doing something one
Right.
at a time. There's
Right.
happening.
It's pulling or pushing. You want to do push, no problem. I say it's pull. But what it's doing is one iron filing at a time is coming closer to the magnet. You got to explain what came in contact with the iron filing. You cannot say nothing came in contact with the iron filing because I can't see or touch it. No. Then you're putting angels. You're putting spirits in that same space. You're saying Mother Nature does this with spirits. That's all you said. So you're a religious person because you're introducing spirits. You're saying there's nothing there.
You're saying, like air, you have to give whatever magnetism
Right.
is shape so that we can see, oh, okay, so it's like a rope that's doing it, or I don't know, it's balls hitting
Right.
each iron filing and throwing it to you or something.
How do you explain air to someone? I mean, if you want to try to explain it more or less logically, like I said, maybe to a pygmy or whatever out there in the jungle, well, you would say, look, let's assume that this thing that's here is made out of atoms. These are the atoms, okay? They form these molecules, a bunch of balls, yeah, they're all in there. And we're saying that this is floating around for whatever reason, and this is what we're breathing. So you would explain a phenomenon in that way. Can we see the atoms? No. You draw them and you say, this is what I think is in that invisible region. And that's the same thing we do with light. We say, what is light? Well, some people believe it's a series of particles. So what do? They draw a bunch of particles. Other people draw a wave, and they say, well, I think it's a magnetic and electric field. They go at 90 degrees, and they draw this, the famous field. Magnetic and electromagnetic field.
Invisible, visible.
Yeah, what are you doing? Well, you're turning something which is invisible, you're making it visible, so that you can give your explanation, someone can follow what you're saying. Do the same thing with gravity, do the same thing with magnetic field. Just tell me what physical object's in there, draw it. Don't tell me, draw it. Put a picture. an image, so we know what came in contact with one iron filing. Don't talk about the field and
We'll
say,
extrapolate to
oh,
the rest.
that the field has shape. No, we know the field has shape because we see it in the iron filing. Tell me what came in contact, what shape, what thing came in contact with one iron filing. And then we'll know if you know. Okay, then we can use about knowledge.
Yeah. The shape of
Please predict.
Well, the shape of the amalgamation of all the things is a different question.
Yeah.
We just want to know one for now.
We want to know what came in one. Don't make it complicated. We'll make it easy for you. Just draw what came in contact with one iron filing, and we'll be done with that.
We'll extrapolate to the rest.
And here's what a field is. A field is a region of space. Well, this fellow, he did it the other day. A field is a region of space. He put this stuff up there. Yeah. And what is a field? Well, each point is associated with a quantity. So what is a field? A bunch of quantities, a bunch of numbers. And a static field at any given point in space is a number. And that's what good old Nick Lucid, good old Curly there, that's what he put, that's the reference he gave. And that's what good Nick Lucid put in his site. He put a bunch of numbers. He says that's what a field is. So you can't say that a bunch of numbers does anything. And this fellow continue and say, well, those represent atoms.
Represent.
Yeah, because he's got to represent it. And so that's what I'm saying. Here you have two magnets, okay, the little circles there, okay, and there. Okay, these are magnets, right? Okay, are you saying that in between here, there are atoms? Is that what pulled them together? Is that what the field represents? A bunch of atoms that are in here that are pulling these together, or maybe on the outside? What is bringing these two magnets together? Are you saying nothing is there because you can't see or touch it? Is that why it's nothing? Then you're putting spirits. You're doing black magic. That's all you're doing. And so you can't say the field did it because the field is a concept. A bunch of numbers. That's what this guy said is.
We kind of crap on the word represent a lot, but aren't we using representation when we give color to the invisible objects?
We're making an assumption, not a representation. We're making an assumption. We're saying, let us assume.
Let us assume air is a bunch of balls.
Right.
That's not a representation.
Right. You're saying, let us assume. We're going to make an assumption. That's why you don't say, I believe, because that's religion. I've proven that's religion. You just say, let us assume so that you understand what I'm going to explain. Okay. Then you're okay. But as soon as you say, I've proven it, it's a fact, give me my noble, then we got religion. Okay. Okay, a couple more questions
here. You don't
here.
like these noble guys, do you? But...
No, because they're all, it's just politics. It's a club. It's politics. Okay, so I put here, the entire language of so-called science is corrupt, has been distorted beyond recognition by all mentally retarded autists who run and have full control over the world of math. Okay, that's essentially. They use euphemisms, figures of speech, okay, and so on and so forth. That's essentially my conclusion. Particles are not particles. Spin does not mean spin. It's not spinning like a top. You know, I talked about that in the past. It's an orientation. So they don't even know. They don't have a definition for the word spin. But every time they use the word spin, they insinuate that it's what a top does. And that's not what spin is, because what does half spin mean? What does half spin mean? Well, what is this nonsense?
3/4 spin.
They're giving you numbers to spin. I spin the top and, oh, that's a 3/4 spin. So yeah, they have all these euphemisms. Straight is not straight. When they say straight, they mean rectilinear because they're talking about motion and not about something that is straight. Flat is not flat, and so on. They have euphemism. Infinity, we just talked about that. Infinite and infinity. There's no such monster in physics, in science. So you can't use these words. They use all these words because they come from mathematics. That's why they've introduced them into physics. You can't use these terms in physics.
They thought the words would help, but they didn't.
No, it just confused everybody worse because people say, well, they observed. No, they didn't observe anything. You can't observe anything in the real world, in the invisible world. All you can do is make an assumption. But when they say observed, it's like I saw the particle. I saw the virtual particle, for example, right? Okay, last two questions, and then we'll open up the floor.
We got like 2 or 3 questions.
Okay, so
Good ones.
Okay, so let's go with this. Gravity is in the same configuration as magnetism. That's what this fellow says. The shape of magnetism around the planet. Well, there you have it. Does a gravitational field look like a magnetic field? First of all, you have the magnetic field in the North Pole, at least. You know, you can see that they go in and they come out the South Pole. Maybe it's the other way around. Who cares? The point here is that pattern there, formed by the magnetic field of the Earth, does not match the gravitational field of the Earth, which is all towards the center. So you can't say it's the same configuration. Gravity is not magnetism. You got this from the electric universe. They believe in this stuff, that it's electricity or magnetism. These people are
There's
insane.
Different shapes.
At the center of a planet is zero gravity, environment point, source 0 point. Yeah, and that's different than what you have for magnetism. We can see that it's, we can see that it's acting the same way as magnetic attraction with a Cavendish experiment. Absolutely not. And there you say, I don't need to go beyond this. Gravitational field is not the same thing as a magnetic field, and
the effects have different shapes.
They have different. This should be basic. This should be kindergarten stuff. But
and we just saw with the iron filings.
Some people just drown.
They didn't all go in. They kind of did this weird.
Yeah, and that's not what gravity does. Gravity is always directional. That's why they had to invent negative gravity. You know, because you have.
Doesn't that just push?
No. You got to understand this. What is dark energy? Dark energy is negative gravity. What you have is gravity should pull everything in. So we had this big explosion known as the Big Bang, right? 14 billion years ago. So everything's expanding. You say, well, why doesn't all that get pulled back by gravity? I mean, you have all this matter that should be pulling at each other. And so they said, that's because we have this negative gravity, and we're going to call it dark energy, which is pushing everything out against the gravitational pull of mass. That's what dark energy is, and that's what they're studying. These bean brains that call themselves mathematical physicists, that's what they do. They study dark energy, which is allegedly negative energy. If gravity is pushing out, and that's the positive gravity, the negative gravity means pulling in, and that's what dark energy is, the opposite of gravity. I said it in reverse. It should be.
Yeah.
Gravity,
you lost me.
Okay.
Gravity pulls in. Gravity pulls in.
And we'll call that positive gravity. Negative gravity is pushing out, and they call that negative gravity. They call it dark energy. Yeah. That's what pushes everything out. That's what they invented, the opposite of gravity. Yeah, anti-gravity.
Anti-gravity.
Yeah,
that's
dark
sci-fi.
energy.
I've seen that sci-fi. They have the anti-gravity.
No, it's not sci-fi. It's called science.
Oh my goodness. Science. Science, non-fiction.
Last question, and then we'll open up the floor here.
Where do you get these questions? Like the ones that you're putting?
These are from last week. People who put comments. They put comments in the video.
Huh.
Okay, last one here. Objects. 3-dimensional is a requirement in physics. He says that an object has to be 3-dimensional. Okay, we don't know what definition he's got for 3-dimensional. I guess it's that one down below because that's the one he put. Okay, and again, the physics definition of object in Wikipedia originated from physics dictionaries. Absolutely not. What does the Wikipedia say? In common usage. It doesn't say the physicist said. No, it says in common usage. They don't have a definition for the word object in all of science, in all of physics. Why? Because they don't use objects in mathematical physics, and those are the people who are in charge of so-called physics.
They don't care about objects.
They don't care about objects. So there is no definition of the word object because they never realized that you can't do physics without objects, and they don't because they're going to be doing equations. They're not going to be doing moving objects around.
They do physics with the shape, with the length of the object. They do physics with the location of the object, but they don't do anything with the object itself.
And that's one issue. The other one is that they don't give any importance to physical interpretations. They call that philosophy.
Well, they get a little bit because they at some point they throw in their 2 cents.
No, but when you put them against the corner, you say, hold it, that's irrational. They say, we're not supposed to take it literally. Or they say, well, that's philosophy anyway. That's a belief.
This poor dumbass, he thinks I'm being literal. It's a representation, obviously.
And then again,
what's the non-representation of it?
Is that what an object is? A collection of matter? Here you have a collection of apples. Is that an object? A collection of apples?
A pile of apples. Is
that an object?
It could be.
Doesn't look like an object. It's a bunch of apples. And is light mediated by an object? We need an answer to that. Is there an invisible, intangible object in there that mediates light? And there you see a whole bunch of lights crisscrossing. Do the little photons ricochet? They bounce against each other and pop out? Like when you put two hoses, water hoses against each other, you'll see the drops hitting each other and bouncing out. Is that what you see with light?
Well, the photons are really small.
Yeah, and they have all this these weird explanations where they turn the photon into a particle-antiparticle pair that recombine again and turn into a virtual photon. That's how they explain all this nonsense.
Do they have to dodge the other particles?
Yeah, you should. Well, they do it.
When they're about to hit each other, they turn into non-particle, let it go through, and then they turn back.
They do it with Feynman diagrams. It's all nonsense, all math. It's just saying, well, look, they split up, they turn into particle-antiparticle pair, then they recombine, turn into a virtual photon again, and they continue, and then the detector detects that. And so through this rigmarole, they try to give you a physical or a semblance of a physical interpretation. And you say, well, what caused the photon to split up into positron and electron pair?
Now you're just asking extra questions. And
they never explained that. It does. It did. And what is that? That's magic. That's just magic wand.
Well, you got to use magic at some point, don't you?
Yeah. So do I. Here's my magic wand. Abracadabra.
But at some point during a theory, you have to say it just does, don't you?
Well, again, science should be assumption, explain the theory objectively so that a person understands we're done with science. What continues then is religion, belief, your opinion. You take it home, you believe in this one, the other guy believes in the other theory, okay? How did the window break? This guy said, well, a dog jumped through the window. The other guy said, no, it was a baseball bat. The other guy said, no, hit it with a crowbar. So you have all these different theories of how the window got broken. And all you do is explain it rationally or objectively and say, look, this is what I think happened here. The other guy says, this is how I think it happened. And then everybody leaves the scene and everyone can believe in whatever they want to believe. That's religion. The objective explanation is the only part that concerns science.